భార్యని ప్రేమించాల మా భార్యని గౌరవించాను.
ఓకే. Hi all, good evening. Uh, we'll start in another 5 minutes. I'm expecting more people to join. Hey Ayush, I just read your message. Lakshmi will be texting you separately on that. Currently, for the past 2 days, the recordings have been shared as a link over the groups that you have joined. So you can find them there. Maybe sometime later, I myself will be telling you where to find the recordings, or if you can ask Lakshmi, she can help you with that. Can
Yeah, no issue,
y-
no issue.
yeah, my voice is audible, right? I hope it
Yes,
is
yes,
clear.
yes, yes, yes.
Yeah.
It's good.
I think I see a few new names. If somebody is new, can you introduce yourself? Maybe your name and your experience. Veera, like I see the display name Veera. Did you join yesterday and the day before?
Uh, no, I'm new actually, joined today,
Mm-hmm.
but I was actually I'm working as a data engineer with SAP.
Okay. Okay.
Yeah, I want to get into the automation and yes, that's something I just want to understand and get into this.
Okay. Very nice to hear that from you. So, like, in the group that you have joined, you will be having links of recordings of yesterday's class as well, like
Yeah, yeah,
yesterday and day before.
yeah.
So, like,
Okay.
if you watch those videos and then rewatch today's session, you'll have better idea. So, if you have any questions or anything, like, you can just visit yesterday's and day before's video. You'll have first, if you go to the demo class video, you will have better understanding of what this course is and what can you expect from this course, what are we teaching in this course. Okay.
Yeah, sure.
And
Yeah.
I see another new participant, Pre. I see a display name Pre.
Yeah,
Are you
good,
also new
good,
here?
yeah, good evening, everyone. So I'm Priya. So I've got 15 years of experience in QA. So I've been working mainly on manual testing and automation testing. So I'm joining this course to learn AI testing a bit and the
Okay.
different topics that you're going to cover.
Yeah.
Thank you.
Thanks, Priya. Anybody else is new here? I think I have seen all of you before. Your names I've read before. Feels like that, but I don't know. We'll wait for another 3-4 minutes. Yeah. Out of people who have joined, how many of you have already enrolled with the course? You can raise your hand. I'll just have a count of people.
So I need to go for the syllabus and then might be on Monday I will enroll for the course.
Yeah, like you can take your time. You can watch the demo videos and we can connect with our team. Yes. I see 5 people have raised your hands. Okay, nice. And how many of you have joined the demo class in yesterday's class and still planning to join? Yeah, people who have raised their hands can bring them down. How many of you are planning to join maybe in next 1 or 2 days? Okay. So maybe like the thing is demo class and yesterday and today's class. These three of classes, the recordings will be shared or we have a common link to join for these three classes. And maybe from Monday, there will be a separate link for the people who have enrolled or separate meeting room for the people who have enrolled. So maybe try to enroll as early as possible because from Monday, there will be no free access to the meeting room. So like connect with our team and get started, guys. Yes, Suryakant, you can bring down your hand. I've seen you. Yes. Still there are 19 people. I'm expecting 2 or 3 more people. Or let's just get started and then just have a recap of what we have discussed in yesterday's class and the day before's class. Okay. So like let us at least have this particular first 10 minutes have an interactive one. So if you have if you want to add anything to what I'm saying, you can unmute yourself and tell be part of the discussion. Okay. So in the first class, in the demo class, what have we discussed? Or in the first class, what have we discussed? We have discussed what is actually AI testing, is who that this particular AI testing role is for, what are upcoming roles or highly demanding roles in AI testing, and what is the chances of uh, p- packages or compensations that can be offered for those roles. And then uh, w- we have also discussed what are different scenarios that we test AI engines or generative AI applications. And also we have discussed different parameters that are to be validated as part of testing AI engines. And also, we have discussed a little about different uh, frameworks that are going to be used. And also, we have discussed most importantly, how is it different from traditional testing? Why are we not going to use PyTest or some kind of Jmeter or all these kind of tools here? And how is it different from traditional testing? We have discussed. Right? Did I miss anything here? Suma? No, I guess. Chitra?
Hi. I'm keep thinking about the eliminating PyTest from this. So why is that? PyTest is meant for unit testing. So how would you do unit testing of this application without
Yes.
using PyTest?
Yes, here we have two different things. There is functional testing and there is AI testing. For functional testing or for individual component-based testing, we will be using PyTest. But when it comes to AI response-related testing or testing behavior of AI, there we are not going to use PyTest. You will have better understanding once we go further. Like once we get into the Python or once we get into writing code, you will have better understanding, Chitra. Okay.
Okay.
And yesterday, uh, we have discussed about like the main core idea of yesterday's class was like if we are going to test these AIs or models without having proper clarity, if we go and start testing them, we will be always guessing its behavior without having a clarity or without having proper knowledge. We will always be guessing and we will not be properly able to test those systems. Now, as part of yesterday's class and today's class, we have aimed to understand how these things work and what are these AI components are, what is machine learning, what is deep learning, all of these things we have discussed yesterday. Okay. And also, we have had a small glimpse of what are tokens. Right, and today's class will be a continuation to it. And yesterday, most of you might have felt like we are discussing something too much technical, but no, it was not that deep into technical. We were just understanding an overview of different concepts that were involved. We have discussed that AI is a learning system and machine learning, deep learning, these both are subsets of AI, and those also comes under AI itself. And we have discussed what is machine learning used for. Used for. What is machine learning used for? Machine learning is used for predicting future values or predicting data based on the data that was trained for the model. Ayush, I see you have raised your hand.
I would just want to say I don't mind going into much details since on my current job I'm already uh, working on the AI things. So I feel it's better only if we are aware of the at least
Components, yeah.
little bit of technicalities we are aware of.
Yeah.
So there's
Uh,
no harm in going little bit of detail or maybe doing some homework at home just to get into little bit more technical side. There is no harm in it.
yes, true, Ayush. So here, like, whatever concepts that I'm covering in this particular series are definitely going to be helpful for you some or the other day or in the process of testing these AI systems. Okay, so now I'll just give a brief explanation or brief recap of yesterday's discussion. Okay, we have discussed that AI is a learning system to which past data is given, and based on the past data, an output for current data is given or future data is given. Let's say I'm taking the same example. Let's say I have a grocery store and I have data of me buying out all those stocks and putting them in my grocery store and what are being sold, what are not being sold by the end of the month. All of this data is there with me as part of a table. And now if I train my machine learning model or a model, a deep learning model or a machine learning model or AI, if I train it, I will get responses like in the next month. What are different items that I have to bring in into my store? Or what is the demand that is going to be in coming few days? Or let us take another example. Okay, let's say I have data of people who have defaulted loans. Okay. And the data could be like their salary, their buying patterns, and their credit score, and their occupation, their age, their education, all of these details, I have it with them, with me. And now I also know how many of them have defaulted those payments, how many of them have not paid their EMIs or loan amounts.
Sir, we are not able to see your screen.
Yeah, I'm not sharing any screen. We are just discussing what was
Okay.
discussed yesterday. Yeah, I'm
Okay,
not
thank
sharing
you.
my screen. Yes,
Yeah.
Veera. Yes, Veera.
No. I whatever by mistakenly. Yeah, I'll go
Yes,
through and I'll come back to you.
yes. And also, like, if you have any questions, let's save them for last 10 or 15 minutes. And if you want to, like, if you're facing any issues, like Priya had thought that I was sharing something and she was not able to see. In things like that, or if you're not able to hear my voice, in such cases, you can unmute yourself and let me know. Fine. Okay. I'm not sharing my screen. I'm just talking with you guys. Just consider this as a kind of discussion. Okay. And now, where was I? I was talking about fraudulent transactions or loan defaulters. Now I have data of previous customers who have defaulted the payments defaulted their EMIs. Defaulted in the sense they have not paid their payments. Okay, and also I have data of people who have paid their did their payments on time also. Now I'll take all of this data and train my machine learning model or deep learning model. And next time when I just give the details of a customer, it will predict. It will not give a kind of decision, but it will predict that how this customer is going to be. If he's going to be paying all these EMIs or time, or we can suspect him. A kind of these kind of machine learning models are built and are in production at multiple NBFCs and banks, right? So now this is machine learning, and if one machine learning model can do this much, how a set of machine learning models, all of them paired together, can work on? How do they find the relationship between all these parameters? That is how deep learning has evolved into. Deep learning model consists of multiple small models, small weak models, which are called as perceptrons, and all of them are paired. Yeah, let me share my screen. That will be better for you if you see it. I'm sharing my entire screen. I hope it is visible to you.
Yeah, we see it.
Yes. We have discussed what machine learning is. Machine learning is a system where we give in data and that particular model will find out what is the relation between those parameters. What is the relationship between his age and his salary, and with the loan defaulting parameter. Like that, it will draw out a kind of mathematical equation which will be helping the machine learning model to predict for future data. Right. Now, what is deep learning? Deep learning is a concept where all these small models are paired together as form of layers, and each layer will consist of a few number of models like this, which are called as neurons. Since we are calling them as neural networks, each model that is there in each layer is called as a neuron, and a pair of neurons is called as a layer. Now, this multi-layer models paired together as a network is called as neural network or deep learning network. Okay. And from here, we have transformed into something called as transformers. And from transformers, we have evolved into LLMs. We are going to discuss that part today. Now, till here, we have discussed everything related to models. But what is data that is going to be given into these models? What kind of data is going into these models? Mostly, all the use cases that we have discussed so far are like the data that we have are numbers, or end of the day, they are predicting fraud or not fraud, binary or fraud, not fraud, maybe kind of things, where the output is a fixed number. There is a fixed number of outputs that this model can give. And also the input that we are giving can be represented easily using zeros and ones. Let's say there is a parameter called as gender. Okay. I can specify it using 0 and 1. Okay. Or let's say there is something called as education. We can rank the education, like undergraduate you can consider as 0, graduate you can consider as 1, and PhD I can consider as 2. Like that, I can order them and convert them into numbers. But all these kind of data is considered as structured data. And for structured data, the output that we are expecting is also in a limited number, right? But when it goes to something like an unstructured data, something like an image, something like an audio clip, or something like a text, if I give in all the text that I'm talking now, a transcript of our entire class to a model, we always know and we have always been studying that machines don't understand your language. Machines understand numbers. In the same way, these machine learning models will also understand only numbers. That is why we have converted all the data that was even text into numbers, numerical representation of those labels. But end of the day, they were all in limited number. But if I have to give the transcript of this class to a machine learning model and ask it to predict what am I going to teach the next day, will it be able to do that if I give the simple text? Yes, in current scenario, but in a scenario where machines only understand numbers, in such case, how will how will my textual data will be understood by my model? Any guesses?
The LPM, natural language process, which you told, it'll use tokenization and convert into numbers and
Yes,
then pass it on. Yeah.
yes. I think I forgot to mention my name or introduce myself to the people who have newly joined. Sorry, myself, Takshin Verma. You can call me Verma. And I am going to be the trainer for the entire series of this course. Okay, thank you. Right, let's get back. So now, when I am saying that all these textual data is going cannot be understood by the model, how am I going to make it understand? By converting or by finding a way that can convert all this textual data into numbers, right? I have to convert all these textual data into numbers. Sounds interesting. But how do I do that? Can I give numbers like A equal to 1, B equal to 2, C equal to 3? No, right? That cannot be done because English is a vast language where, and also contextually, there is a lot of similarity. At the same time, there is a lot of difference. Let us take an example. Okay. If I say bank, what does it mean? What does it mean, guys? What
Financial
is
bank,
bank?
it could be river bank, it could be
Yeah, it could be a bank. Bank could be a
blood
place where
bank.
blood bank. Yeah, it could be a place where I save my money, or it could be a place near the river. It could be both. And if I have some kind of numerical representation, maybe based on letters or maybe by ranking these words with numbers, English is a language where same word will have different meanings when placed in a different sentence. Now, how are you going to handle such scenarios? That is what we are going to learn today. That is what we are going to understand how all this is going to happen inside head of a machine learning model or the transformer behind the LLM. Sounds interesting, right? Now, as part of today's class, I'm just giving you a heads up of what all we are going to learn. Okay. Why NLP is special? What are different concepts that are involved in NLP? What is tokenization? I'm going to demo the token sensitivity, how a small change in token will completely change out the response. Okay, I will explain the numerical representation of these words, which are called as embeddings. And I'm going to explain you what is contextual embeddings. And then we are going to have a glimpse of what is a transformer and the transformer architecture. We are not going deep into what are different models that are there in the transformer, how many number of models are there in each layer. No, we are going to have understanding of how these transformer architecture models respond. That's all, right? And there is an important concept called a self-attention mechanism, which is used for generating these texts or tokens. Okay, and by the end of this session, we will understand what are actually these large language models. What is ChatGPT using? What is Google Gemini using? And how is a next token predicted? And there are different parameters that are given to a model. Like, let's say if the model is being used for prediction, how it has to predict, how many tokens it has to use, how much creativity it has to use. All of these we are going to discuss. Okay. and we are going to discuss about context window for today, and then rest we will be learning from next class. Okay. Right. Let's come back to the place. What is NLP? Okay. Mm, how do I tell you? Yes, I've taken the same example. Language is tricky because the words change meaning based on the context, based on the place they, based on the placement of that particular word in a sentence. Let's say if I say the bank is near the river, bank is land. Okay. If I say I deposited money in the bank is finance. Humans understand instantly, but do machines do the same? No. Right? Language is unstructured. Language is ambiguous, context dependent. Okay. So now what will this NLP help us like what can be done to remove this scenario, to solve this scenario? NLP breaks these texts into small texts, some meaningful texts, and then convert these texts into numbers. After this is converted into numbers, from those numbers, it will understand the context and then they will predict. Okay. Let's just relate it to the testing mindset. In traditional testing, input is structured. An API is there, it gives a JSON and it is predictable. What structure of JSON it is going to give is also predictable, right? And we will always know what are different parameters of that JSON that we have to give as an input for request, or the response that we get, what are different values that are available in that JSON, everything we know. So it is predictable. But in NLP, input is free form human language. There are infinite variations, right? There are infinite variations. You can ask me, like, what is NLP? Priya can ask me, Orma, what is natural language processing? Both of them are correct, but still both of them have a variation. Okay. This is where NLP helps us to understand them. Okay. Let's say, let's jump onto the topic called as tokenization. Okay. How does a machine read a sentence? It does not. It does not see. Let's say I use a phrase like I love AI, but still it sees numbers. Imagine breaking a chocolate bar into small pieces. Tokenization is the same concept. Breaking the sentence into small pieces. Let's take the word artificial intelligence. If I take the word artificial intelligence, it can be broken into art, official, and intelligence. Okay. And these small changes or these small tokens are converted into numbers. Or how am I going to do this tokenization? We as testers are not going to do anything as such, but we are going to understand how it is done. There are multiple tokenization algorithms. There is sentence piece, there is word piece, there is byte pair encoding. These algorithms will chop these sentences into small tokens. Tokens are not always words. Sometimes they are statistical subword units also. Like here, official does not hold any meaning. But when it is paired with artificial, it has some meaning. Okay. And the main part here is because of these tokens, different tokens will result in different embeddings and different output behavior. So small change in wording can also differ the output response. So as a testers, when we are going to test these LLMs, when we are going to write these test scenarios or uh, test cases, how are we going to write? Same sentence with a different wording, with a different token we have to test if it is responding in the same way or not, or if it is still holding the same contextual value or not. Okay. That is the reason we are understanding this concept of tokens. As I said, each of them will give me different meanings, right? Like different responses, right? Now I'm going to show them live to you. I've opened Chat GPT here. Chat GPT is a tool which works on LLMs which are provided by OpenAI. Okay, here I'm going to type, hi, explain me what is testing. Okay, it had responded in some way. It has first given the explanation and then in simple words and then different types of testing it has given. And now I'll go back. I'll open another tab for a different unit of the same model. Now here, instead of saying hi, instead of asking what, that, this, I'll just say what is testing. See, now it had responded differently. Now which one is correct? Priya, which one is correct? Here it is explaining some way. Here the structure has completely changed. Now what will I do? I'll again have a duplicate one. I'll say, uh, can, can you explain what testing is like you explain it to a 5-year old? Now, all of the sentence that I've used is almost similar, but here I've just added few more tokens which says explain it to a 5-year-old. And now the context has completely changed and the response structure has completely changed. See, now it has taken example of big tower with your blocks, all of these things. It had taken an example, it has given smaller response now, and it has not given me what are different types of testing because as a 5-year-old, I don't know what different types of testings are. It cannot explain me directly until I understand what actually testing is, right? That is how the change is there from question to question or from input to input based on adding just a few more tokens or just replacing one token with another one. If I ask what is AI, it will give me a different response. And if I ask what is artificial intelligence, it is going to give me a different response. And if I ask the same question again also, it is not going to respond to me in a similar way because then the probabilities will change again. It will have to give the response, it will have to frame the response, and that is how it works. With each change in these tokens, the response changes because different tokens will have different embeddings and different output behavior. I hope I am clear. Guys, any question till here? Is my pace okay for you? Am I going fast? Am I
No,
speaking
I'm
to
good.
myself?
No, you're good.
Yeah,
Yes.
I'm good.
Okay. Now we are going to jump back to the PPT. Where is it? Yes.
I wanted to specifically ask what is embedding in a sense.
We are
So,
reaching there.
oh,
We are
yeah,
reaching there. Yeah.
tokenize. Okay, okay.
Yeah. I'm just going to explain the same with you. Okay. What, like, let's say we spoke like we will chunk these words into smaller words or sentences into smaller words, and then we are going to convert them into numbers. Embeddings is the process of embeddings is a representation of these numbers in a kind of dimension. Okay. Imagine, imagine, like computers don't understand these words, right? They understand the coordinates. They understand the coordinates in a different space, right? To assign those coordinates to these words, we use something called as embeddings. Okay. Think of Google Maps. Every place has its own latitude and longitude coordinates. Just like that, imagine each word having their vector coordinates. Imagine there is a complete multidimensional space where each of these words are having some coordinates. They are lying somewhere in that particular dimension. And we are going to understand those words maybe internally based on the coordinates. In Google Maps, if you look at that screen, you'll see all these places, names, and all. But internally inside that Google Maps engine, what is being understood? Maybe you'll give it the location. By saying that you are sharing your location on WhatsApp, what are you sharing there? You are sharing your coordinates in the coordinates of latitude and longitude. In the same way, imagine converting these words into the coordinates in a multidimensional space. Okay. And after converting these into vectors, these are thrown into those spaces. Now, since they have these coordinates, they lie somewhere in that space. But how am I going to know which word is where or which particular token is where? That is where the concept of embeddings comes in. Embeddings will hold that semantic meaning. Embeddings will capture that linguistic relationship. Let's say, like, that means embeddings is a kind of representation of these vectors where they are close to each other based on meaning. Okay, if I say I given a sentence like I left my shoe in front of the door. This is the sentence. Now door goes into a different place. Gate and somebody else says, "Oh, I forgot and I left my shoe or I left my slippers in front of the gate, main gate." Now, both of these sentences are completely different. One has left their shoe in front of the door, and somebody had left it left his slippers in front of the gate. Now, slippers and shoes, both of them are nothing but your shoes or whatever you wear to protect your feet. Now, both of them will have same meaning. Same meaning in the sense, at least same context. Both of them go sit in a small space in this vector space. Okay. Both of them are close to each other. And now, when I'm saying gate and door, both of them are for protecting house. So they hold a similar contextual meaning. Both of them go sit there in some place, some kind of place where both of them are together. Now, if you think of something like a vector arithmetic or vector maths, king and queen, both of them hold same position. Okay, king and queen, both of them hold same position. Both of them are in same vector space close to each other. But the only difference here is gender. Now, if from king vector, if I remove a man and add a woman, it becomes queen. Like that, there are like in simple words, I just don't want to complicate things for you. There, imagine there is a space, there is a vector space. All these words are thrown into that space and they fall into a place based on this context or the meaning that they hold. Now, these words are located at some coordinates in that vector space, right? Those coordinates are called as embeddings. Clear? I want you to ask questions on this if you have any doubts.
So we do it for every input we do put to the LLM, correct?
Yes, we do it for the every input that is given to the LLM so that the machine will understand it.
And there are already inbuilt embeddings from the training earlier done by the model
Yes,
existing.
yes, yes. There are
So
already
do we
embeddings that are there.
add it to the existing embeddings, or we keep the existing embeddings as a reference and then we
Huh.
kind of try to map where all this new conversation falls?
Yes. So now, yeah, as of now, whatever we have discussed, this is a concept of training these LLMs. Okay, how LLMs are trained with these words. Now, when I go there, okay, when I go there and ask a question like that, where did you leave your slippers? If I ask, as I said, the model is trained on two sentences. I have left my slippers at the gate. I left my shoes on in front of the door. Now, both of these sentences are trained into here, trained into the model like LLM. Now, if I go there and all of these models will already have a lot of text corpus fed into it so that it will have understanding of all these words with vectors, with these embeddings. Okay. It is like the entire English vocabulary is fed into this machine, like these LLMs are these deep learning networks. So in this vector space, not just your slippers and shoes, there are somebody else's shoes as well, like somebody else's words
So
as well.
whole, so as a whole English vocabulary is
Hmm.
already existing in this vector space in form of embeddings.
Yes,
Okay.
everything. That is where the concept of embeddings model comes in. This embedding models will hold all the embeddings of that, all the embeddings. So now OpenAI models are there. OpenAI models will have OpenAI embeddings. Okay, and Gemini will have Gemini embeddings, and Claude will have its own embeddings. Like that, embeddings change from provider to provider. Okay, now, now if I use a model to feed in the data, to train the data by using, like, okay, I will tell you the process of prediction now. When I come and ask, bro, where did you
I
leave
have a
your,
question. I have a
yes, Chitra,
question.
yes, yes.
Okay. So, can you explain the corpus one more time, if you don't mind?
Yeah. So what I was telling is, first we have understood the representation of these things. Whatever words are there, I am throwing them into a vector space. Wherever they fall according to their contextual meaning, I'm finding their coordinates and understanding those words with those coordinates. And the main logic here in this space is similar words fall into similar spaces, like closed spaces. Clear till here? And now
Yeah.
each of these providers, OpenAI, Gemini, or Llama, all these peoples have their own vector spaces. Okay. They're not dependent on each other. They will have their own dimensions, they will have their own vector spaces. Now, each of them will have the big text corpus which they have trained their embedding models with. And now, for embedding models like OpenAI, the coordinates are different. And for embedding models of Gemini, the coordinates are different, but for them, they understand it better, right? This is a process of representation. Okay, now, how are these going? Like, yes, contextual embeddings. Like, these words are going to be paired with the coordinating words in a sentence, and context is understood based on the placement of other tokens in that sentence. Okay, now, before we will talk about transformer architecture maybe in next class, but we will understand specially what this prediction is done by. How is this prediction done? Now, I have these embedding models, right? I understand it.
So I've got the question. Will you show
Somebody,
us some
some
data?
who is this
I mean,
speaking?
Priya speaking.
Yes, Priya.
Yeah,
Can you
I was
talk
just
a little
asking.
louder?
Yeah, are you able to hear me now?
Yes, I'm able to hear you.
Yeah. So I was just asking you, will you give us some exercises about how to train the LLM?
This particular class, we are not going to train LLMs, Priya. We are going to
No,
test
just give,
LLMs.
yeah, to test LLMs and how to create these
Yeah, we are
test
going
data.
to, like, as part of this course going forward, I'll be giving you exercises and I'll be providing you solutions for them as well.
Yeah, yeah. I was just asking for that.
Yeah. We are going to do that going further. Okay.
Okay,
Now,
thank
I
you.
have
Yeah.
one more question. Sorry, I have one more questions.
yes, Chitra.
So, like, you said ChatGPT has its
Uh,
own embeddings
embeddings. Yes.
and its own vector storage, right?
Yes. Yes.
So how do all I know is ChatGPT. How do I
Mm-hmm.
find the mapping of what exactly the embeddings used by GPT 5.2 or and the vector storage associated with it? Is it possible?
Yes, it is possible.
Find
You
the
can
mapping?
actually, yeah, you can actually find the mapping. You can actually print the vector forms of these responses as well. But that gets into a little writing of code and printing those vectors that we are getting. Okay, but still it
Okay.
is very much possible. Like you can compare the vectors of both embeddings, Gemini embeddings and OpenAI embeddings. Side by side, we can put and understand them. Okay.
Is this a numbers are like mentioned 768 to 409? These are fixed or example you have provided?
Example, like typically 4096 is the amount of dimension that is currently there in LLMs. Okay, 76. It could be like Gemini could be using only 768 dimensions, and OpenAI could be using 4096 dimensions. Currently, like the highest dimensional vector space is of 4096. Uh, I I also don't remember which embedding model is having that many dimensions, but this is the typical number of dimensions that are there in this multi-dimensional vector space of each model provider. Okay, and the craziest question here: are we going to do all these things by ourselves? Or not just I'm not talking about testers or developers. Are we common developers or testers going to do all these things? Are we going to build embedding models? No. We are not going to build any of these embedding models or anything. All of these are already fed into these LLMs, and we are going to use them as APIs, or we are going to run them inside our systems or our computers. That's all. We are not going to train these LLMs. Training LLMs is a very complex task, and that is done on very high compute systems. We cannot do it on our systems as well. We cannot train a simple LLM on our system. It requires a high amount of GPU, it requires high amount of power. All of these things are there. So we are not going to do them. But why are we learning this? To understand how things work. Okay. Now, I hope the concept of embeddings, I have explained it in a simple way. I'm going to take all these words, the full text corpus of words, and I'm going to throw it into in the sense, the OpenAI guy had did it. Okay. Now they've thrown it into their multidimensional space with one rule: words with similar meanings will end up in similar coordinates. And now, based on the coordinates where they are in this multidimensional vector space, they're representing them with those words. Right? Am I clear till here?
Oh, yeah, just one question. I understood till semantic meaning as in placing it with the similar words. But what is a vector arithmetic? What does that do?
Vector arithmetic, I have taken a kind of example how these to explain you better how these words are close to each other. Like king and queen, both of them are close to each other. They share same space or same neighborhood in this vector space, but still they both are different words, right? What is the main difference here? Only the gender.
Gender.
So how similar they are? The word king has a vector space and man has a vector space. If I remove man from a king and add women, that becomes queen. That means they are close to each other, but still they are distant from each other because of some other influencing factor, which is gender here. Right?
So like mathematical relationship you are seeing. That's
Mathematical
what you're trying.
relationship, which we are not going to actually use, but just to
Okay.
explain you, I have taken that example.
Okay. Got it.
Okay.
Can
I
you
have
give
one
one
more.
more example, Varma? Because I'm not clear
Okay.
about this.
Okay. One more example is like, let's say, yeah, there are two different vehicles that are going, like I have two example of two different vehicles, a car and a lorry. Okay. Car and lorry, both of them are like car and a bus. Okay. Let's not confuse you. Car and a bus. Car and bus, both of them are moving vehicles used for transport. So now these two words will share same neighborhood within the vector space. Am I correct?
Yeah, yeah.
Right? Now, these two words are close to each other, but why are they not in same coordinates? Because both of them have a semantic difference. What is that semantic difference? Semantic meaning difference. Car has four wheels and only four people can go in it. Four or five people can go in it. Right? A bus has 6 to 8 wheels and more than 40 people can travel in a bus. Right? Now, if I remove four wheels from the car, just an understanding, we consider this particular vehicle as a box, and I remove this concept of 5-seater and add 40-seater, that word will become a bus. Like, leave it. Like, now both of them are close to each other because it holds a meaning of carrying people to their destination. But both of them are different from each other, like close to each other, but still there is some difference because they hold a different contextual meaning. That's all.
Got it.
Okay.
Got it.
Yes. And what happens when these words share same spelling, same meaning? Okay, but share bank. I'll just like the example that I've taken before. Bank is always having a same vector. Bank is a word. Without placing it in a sentence, I will never know what this particular word means. So now these modern LLMs will look for other words which are there in the sentence, and based on the words that are there in the sentence, using something called as self attention mechanism, they will understand what actually this word bank really means based on the other words that are there in the sentence. That is called as contextual embedding. Like, this contextual embedding concept or the self attention mechanism concept with transformers, we are going to learn in tomorrow's class. Okay. Like, I can give one example or one understanding technical explanation of this contextual embeddings is transformers produce these contextual embeddings. Each token embedding is influenced by its surrounding tokens. Okay. Now, this token will not just have a meaning by having its own word, like this word is having a meaning, but still when it is put into a sentence, the surrounding tokens will change its value because both of them are paired together in a function. All of them are paired together in a function. Each token support other tokens to form a context, to form a meaning that we are going to understand in tomorrow's class. Okay, as of now, that's all for today's class. And as of now, whatever questions you have, shoot.
Hi, Verma. I have a very basic question. I'm still
Mm-hmm.
trying to, I'm sorry if I'm asking to read. So,
No issues.
I'm still, yeah, because I have no idea about since, the AI testing at all. Like,
Mm-hmm.
it's completely different from the traditional testing.
Mm-hmm.
So how we are going to begin with, like you showed us the embedded testing. So is it the same testing we are going to follow, or like does it has like unit test, or like we follow right regression and then
1 second. Give me a
that's
second.
given. Okay.
Sorry, guys. I got some other
No,
important call. Okay.
yeah, no worries.
If you
So
have,
like
if you
we.
go through, like I'll tell you, if you go through the course curriculum,
Mhm.
there are concepts involving how the API communication is made, how the Python script is written, and why all these Python scripts are learned. And other than that, how AI concepts are there, like how AI concepts actually operate, and how do we test them. If we are testing them, what are different scenarios that we are going to test, how to write test cases for them, how to write test scenarios for them, how to plan test plan, all of these things we are going to cover. And also not just that, we are going to
Okay.
deploy these workflows after this test case scripting is done. We are going to have this as part of an automation script, right? And these automation scripts had to be part of the CI/CD pipelines for deployments, right?
Mhm.
I am going to teach you that as well. So we are going to cover end-to-end AI testing, how to write these test cases and how to run these test cases, and then how to automate them. If automated, how am I going to deploy them using GitHub Actions? All of these are going to be part of this course.
Okay. I understood the part what we are going to learn, but
Mm-hmm.
as a like in traditional testing for
Mm-hmm.
product wise, we just
Mm-hmm.
test the
Product
stages, right?
wise,
Like,
yes,
yeah.
product wise, whatever traditional testing mechanisms are there, whatever testing techniques are there, all of
Mm-hmm.
them will still be intact because end of the day, it is also an application, right? But here,
Yes. Mm-hmm.
in place of testing, like there is functional testing and there is something called as performance testing, security testing, non-functional testing, right?
Correct. Mm-hmm.
Functional testing will test the values that are produced by each of these components, whereas non-functional testing will depend on performance, security, the application set of testing, right? That will
Mm-hmm.
still be the same. When it comes to functional testing or unit testing, we are going to write these test cases using deep eval. Okay, we are not going to directly use for, especially for like Chitra, I know you are going to ask again, why are we not going to use PyTest? But here we are going to test the responses, behavior of responses, and PyTest or unit test will still be there for functional testing of the functions or components that are written around or wrapping these LLMs or wrapping these LLM responses. So here AI testing, as part of AI testing, we are going to validate the responses of these LLMs, not the functions surrounding that LLMs or components that are surrounding LLMs. Okay, the components surrounding LLMs, which are not dependent on LLM's response, will still be tested in the same way like before. But these AI components are tested differently. How differently, we are going to learn.
Yeah. Okay, good. Mm, that's all. Thank you.
Thanks. Yes. Uh, I see two more people. Sharanya, no,
Yeah,
Poonam. Poonam. Sharanya, you
Yeah,
have.
hi. Shall I go ahead?
Yes, yes, Sharanya. Sorry.
Poonam, yeah.
Yeah, Poonam. Yes, Poonam.
So as part of the workflow which you showed the diagram of the tokenization,
Mm-hmm.
can you come back to that flow? I had question on that. You said that transformers generate this contextual embedding, right? So this is
Mm-hmm.
happening inside the LLM or
Inside the
outside?
LLM.
That's what inside the LLM, right? Because it's
Inside the LLM.
transformers are doing it, right?
Yes.
And okay.
You were
So first
talking
token,
about this?
uh, yeah. So
Yes.
first we'll be generating the IDs and then
Mm.
it will go to that embedding which you discussed. And then that contextual thing will be happening inside. Okay, that's all I wanted to know.
I'll
Okay.
be sharing these with you. Don't worry. I'll be sharing all of these with
Okay. 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 That's all.
you. Yes,
Thanks.
Poonam. Yeah, thanks. Yes, Sharanya.
yeah. My question was the flow, how it is dividing the prompt into small chunks. It is a random one, or it is first it will analyze the whole question, then it will divide.
So, there is a concept called as tokenization, and for that we have different algorithms which are trained on these texts. Uh, the meaning of these texts are known to those tokenizers. So now, what will they tokenize on based on the meanings? Okay, now each of the word is separated, and helping verbs, all of these are ignored because they don't hold a specific meaning. Like that, based on the context or based on the meaning each of the word hold, they are chunked. Like let's say there is like these are not again you done by LLMs. What happens is like first I have a sentence. Let us consider I have a sentence which is like I want to eat ice cream. This is fine. Now I can chunk this particular sentence into words like I want, eat, ice cream. Two does not hold a value alone.
Mm.
Okay. Now I have a sentence like uh, I would like to have a soda, or I would like to have a big bottle of water after I'm done with running. This is a big sentence which has multiple helping verbs, and there are words which are continuous. Running. Okay.
Mm.
Running. And I love drinking. Like these are words. Now also I will chunk these words into like drinking, running, water, like that I can chunk these words. But drinking is cut down into its root word by removing these ings and all, so that it can be placed into embedding space. The chunking is done that way. First, individual word is separated from the sentence. From there, all the helping verbs will be removed and all these extensions are removed.
Okay.
Okay.
And one more is it is assigning a token ID. The token ID is somewhere related to the vector position or is
No,
different?
just a kind of identifier for each token. That's all.
Okay. Then it will go and do the embedding and understand which it can suit in the vector position
Yes.
and okay. Thank you.
Yes. Any more questions? Maybe related to course, maybe related to the concept that we have discussed today. Absolute silence. Why I don't know. But I hope you guys are enjoying these sessions. You are understanding these sessions.